In software development, quality reigns supreme. A buggy program is as useful as a chocolate teapot. To ensure robust software, we turn to defect metrics. These metrics provide insights into the health and stability of our projects. They help us quantify bugs, those pesky errors that can derail development. Defect metrics offer a clear, objective view of software quality. By tracking these metrics, we gain insights into our quality assurance processes and identify areas for improvement. Just as a doctor relies on vital signs, developers depend on defect metrics to gauge code health. A high defect count might signal a need for better coding standards or more rigorous testing. Analyzing these metrics leads to significant improvements in our development lifecycle. Defect metrics provide a framework for continuous improvement. By embracing these metrics, we embark on a journey towards software excellence, one bug fix at a time. Defect density is a fundamental metric in software quality assurance. It measures the number of defects relative to the software's size, typically expressed as defects per 1,000 lines of code, KLOC. A high defect density suggests unstable software, leading to crashes and data corruption. Conversely, a low defect density indicates a more reliable product. To utilize defect density effectively, establish benchmarks and track trends over time. Comparing defect density across releases can reveal areas needing attention. However, consider factors like software complexity and team experience when interpreting this metric. Avoid drawing hasty conclusions based solely on defect density numbers. Defect leakage occurs when defects slip through the development process and reach end users. It represents a failure to identify and rectify defects before they impact the user experience. High defect leakage translates to user dissatisfaction and potential damage to the product's reputation. It signifies weaknesses in the quality assurance process. To minimize defect leakage, implement robust testing practices throughout the development lifecycle. This includes unit testing, integration testing, system testing, and user acceptance testing. Each phase plays a vital role in identifying and eliminating defects early on. Developers should prioritize quality from the outset. Regular code reviews, automated testing, and continuous integration can reduce defect leakage and deliver a higher quality product. Defect detection percentage, DDP, is a key performance indicator for evaluating testing effectiveness. It measures the proportion of defects identified during testing compared to the total number of defects present. A higher DDP suggests successful defect uncovering, while a lower DDP indicates potential gaps in test coverage. Calculating DDP involves dividing the number of defects found during testing by the total number of defects found. The goal of DDP is to identify and address the most critical defects impacting user experience. Prioritize testing efforts based on risk and impact. By tracking DDP over time, teams can gain insights into testing strategies and identify areas for improvement. If DDP is consistently low, enhance test coverage, refine test cases, or invest in automated testing tools. In software development, speed is crucial for delivering new features and addressing defects. Mean time to detect, MTTD, and mean time to resolve, MTTR, measure defect management efficiency. MTTD quantifies the average time to identify and report a defect. A shorter MTTD indicates quick defect discovery, allowing for faster resolution. Factors influencing MTTD include testing effectiveness and communication channels. MTTR measures the average time to fix a defect once identified. A shorter MTTR signifies swift defect resolution, reducing impact on development and user experience. Tracking MTTD and MTTR provides insights into defect management efficiency. Analyzing these metrics helps identify bottlenecks and optimize processes for faster defect resolution. Total defect count represents the cumulative number of defects identified in a software product. This metric offers a holistic perspective on software health and stability. A high total defect count might raise concerns about the development process quality. Conversely, a low total defect count suggests a mature and well-managed process. Interpreting total defect count requires context, considering factors like software size and complexity. Track total defect count over time and compare it against relevant benchmarks. This allows for meaningful comparisons and helps identify trends indicating underlying issues. Monitoring total defect count provides a comprehensive understanding of software quality. Make informed decisions to improve development processes based on this metric. Not all defects are created equal. The Defect Severity Index categorizes defects based on their severity, allowing teams to prioritize resolution efforts. Defects are classified into 4 levels: critical, major, minor, and trivial. Critical defects render the software unusable or cause significant data loss, requiring immediate attention. Major defects significantly impact functionality, making certain features difficult or impossible to use. Minor defects have minimal impact on functionality, often being cosmetic or usability issues. Trivial defects are cosmetic and have no impact on functionality. By assigning severity levels, teams can prioritize efforts and allocate resources effectively. Address critical and major defects first, followed by minor and trivial bugs. This approach ensures the most impactful defects are resolved quickly, minimizing user impact. Identifying and resolving defects is crucial, but understanding their root causes is equally important. Defect root cause analysis, RCA, investigates defects to determine their underlying causes. By understanding why defects occur, teams can implement preventive measures. RCA involves gathering information, analyzing the code and process, and identifying contributing factors. Collaboration between developers, testers, and stakeholders is essential for comprehensive understanding. RCA helps prevent recurring defects, improve development processes, and enhance code quality. It can also reduce development costs by preventing defects early on. Implementing a structured RCA process is essential for delivering high-quality software. Understanding root causes leads to a more robust and reliable development lifecycle. The pursuit of software excellence is a journey, not a destination. Defect metrics guide development teams towards building robust, reliable, and user-friendly software. By embracing these metrics, teams can understand their strengths and weaknesses, identify areas for improvement, and make data-driven decisions. Consider a scenario where a team faces a high defect leakage rate, leading to user dissatisfaction. Analyzing defect metrics reveals that a particular module developed under tight deadlines with minimal testing is the culprit. The team can allocate resources to thoroughly test the module, implement stricter code reviews, and prioritize refactoring. Leveraging defect metrics helps address root causes and prevent similar problems. This example illustrates the power of defect metrics in driving quality improvement. Tracking and analyzing these metrics helps identify and address process weaknesses. Embracing defect metrics is essential for achieving and maintaining software excellence.